Hello, this video is for IXL Activity A1.I.9. It is titled Rearrange Multivariable Equations. The 3-character code for this activity is Whiskey, Sierra, Juliet. So, rearrange multivariable equations. Well, multivariable because they have more than one variable, so these are actually known as literal equations. A literal equation is an equation that has more than two variables in it. And here we have the variable r and we have the variable c. So this is a multivariable or a literal equation. Now notice they want us to solve for r in terms of c. Well, right now r is over here with the 2 and the pi, and everything is set equal to c. What we want is we want to be able to have it set to where the equation is equal to r. So that is to say that we have to isolate the variable r. And we're going to do this by using inverse operations and solving it that way. So let's go ahead and I'm going to rewrite c equals 2 pi r. And we want to get the r by itself. Well, right now the r is being multiplied times 2 pi. So in order to undo that multiplication, we're going to use division. We're going to divide by the very value, or what we're wanting to get rid of. In this case, it's the 2 pi. So I'm going to divide by 2 pi. And what I do to one side, I'm going to do to the other. Well, the 2 pi's are going to cancel each other, leaving me with just r on the right. And now I have c over 2 pi. I now have r isolated by itself on one side. So r equals c over 2 pi. Just like that, I'm going to use inverse operations to isolate the variable that they're asking us to isolate. On the next one, solve for b in terms of c and d. So right now I have c equals d plus b. Well, I want to get to where just the b is by itself, so let's find the b in the equation. It's here. It has a d added to it, so we need to subtract d from the left or the right, and we need to also do it from the left as well. What we do to one side, we do to the other. The d and the negative d are going to cancel each other, leaving us with b on the right, and then c minus d is c minus d. So b equals c minus d. Solve for s in terms of r, t, and u. So we have r equals s, u, t. And we need to get to where just the s is by itself. So here's the variable s right here. We want to get it by itself. Well, right now s is being multiplied times the variables u and t. So let's go ahead and divide by u and t. What we do to one side, we're going to do to the other. The u's are going to cancel each other. The t's are going to cancel each other, leaving us with just s on the right. And on the left, we have r over ut. So s equals r over ut. Solve for v in terms of p and I. Well, we have p equals I times v. We need to get the v by itself. So p equals IV. And notice that these are capital letters. So on this activity, if it is an uppercase letter, be sure to enter it as an uppercase letter. Otherwise, I believe IXL mark it as incorrect. So if it's an uppercase letter in the problem, be sure to use uppercase letters in your entry for the solution. Well, right now, I want to get the v by itself. Well, here's the v right here. It's being multiplied times I, so let's go ahead and divide by I. And what we do to one side, we're going to do to the other. The i's will cancel each other, leaving us with just v on the right and p over I on the left. So v equals p over I. Solve for w in terms of t, u, and v. So I have t equals u plus v plus w. And I want to get the w by itself. So here's the w. We have a positive u and a positive v. So we're going to subtract u and subtract v. And what we do to one side, we're going to do to the other. Subtract u and also subtract the v. So in this case, those u's are going to cancel. The v's are going to cancel, leaving me with w on the right. And I now have t minus u minus v. So w equals t minus u minus v. Solve for r in terms of s, t, u, and v. Here we have us equals v, r, t. So let's do a rewrite. us equals v, r, t. We need to solve for the r. It's being multiplied times v and t, so let's divide by v and t to undo that multiplication. What we do to one side, we're going to do to the other. And the v's will cancel each other, the t's will cancel each other, leaving us with just the r on the right. And we have on the left us divided by vt. So our answer is r equals us divided by vt. Solve for c in terms of a, b, and d. So we have a equals b, c, d. We need to solve for c, which is here. So the c is being multiplied times the b and the d, so we're going to divide by what we want to get rid of, which is the b and the d. What we do to one side, we're going to do to the other. The b's will cancel each other, the d's will cancel each other, leaving us with just the c on the right. And then on the left, we have a over bd. So our solution is that c equals a divided by b times d. Solve for h in terms of e and f. Again, we have an uppercase E here, so we'll be sure to use an uppercase E whenever we put our answer in. Right now we have E equals h over f. And we need to solve for h. Well, we have a fraction here, right? So let's multiply both sides by the denominator to go ahead and get rid of the denominator, right? F's will cancel each other, leaving us with h. And over here we have e times f. So we just write that as ef. So h equals ef. Solve for u in terms of r, s, and t. Notice that we have this 1 over the u times st. So r equals, now I'm going to do a little trick here. This st, whenever you have 1 as a numerator and you multiply it in, the st just kind of like jumps out from the side up into the numerator. So I can go ahead and put this as st over u. All right, so what I did there is the st that's being multiplied times the 1 over u. Well, anything times 1 equals itself, so st times 1 is going to equal st. So the st just kind of comes from the side here and ends up in the numerator. Now I need to solve for u. Well, it's a fraction, right? So let's go ahead and multiply times the denominator. What we do to one side, we're going to do to the other. The u's will cancel each other, leaving us with the st on the right and ur on the left. We need to solve for u. Well, u is now being multiplied times the r, so let's divide by r to get rid of it. The r's cancel each other, leaving me with u equals st over r. So we go ahead and put that in, st over r. And on this one here, there is a little bit of a shortcut here. Whenever I get down to the, we had r, let's go back to this stage right here. R equals st over u. That was just from my rewrite from up here. I just moved the st into there. Whenever they want us to solve for whatever the denominator is, what happens is that the denominator and the value over here just basically switch places. So if I rewrote this, put the st here, and then the r and the u are just going to switch places. Put u here and put r here, and notice that that is indeed what our answer was. U equals st over r. It's a little bit of a shortcut there. So if you get to the point that you have a fraction and they want you to solve for whatever the denominator is, the denominator is just going to switch places with whatever is there in the first place, if that makes sense. You do this enough, you'll see that pattern starting to develop. So here I'm going to solve for A in terms of B, C, and D. So C equals, and again, I'm going to take this AD and move it up into the denominator. A over D equals B. Now, if they want us to solve for B, we could just switch the C and the B. But in this case, they want us to solve for A. A is not the denominator. It's in the numerator. So I'm going to have to go ahead and continue working on this one. Can't use the shortcut. So we have a fraction. Let's go ahead and multiply by the denominator. What we do to one side, we're going to do to the other. So in this case, the B's are going to cancel each other on the right, leaving us with A times D. And over here, we're going to have CB. Now they want me to solve for A. I see the A is right here being multiplied times D. So let's go ahead and divide by the number we wish to get rid of. And what we do to one side, we're going to do to the other. The D's are going to cancel each other, leaving me with A on the right and CB over D on the left. I've now solved for A. A equals CB over the value of D. Again, all we're doing is we're applying inverse operations just like we would with a normal equation. It just so happens to be that in these equations, they're not actual numbers. They're variables instead, but we just still treat them the same way, use the same inverse operations to isolate a variable like we would normally do. On this one here, we have R equals, and I'm going to take the TQ and put it up there in the numerator. 1 times TQ is TQ. And I still have S for the denominator. Now this is where we can use that shortcut. They want us to solve for S, right? S indeed is the denominator. So I can rewrite this TQ, and now I'm going to switch the R and the S. The S is going to go here, the R is going to go there. Now I could have gone ahead and worked this out. Let's move the answer over to the side here. We'll move that answer over to the side. Remember, S equals TQ over R. Now I can go ahead and work this out, multiply by the denominator, right? The S's will cancel each other, leaving us with TQ on the right and SR on the left. Now I want to get the S by itself, so I'm going to divide by R. What I do to one side, I'm going to do to the other. The R's cancel each other. I end up with S equals TQ over R, which is exactly what I have up here. S equals TQ over R. Final two examples. Solve for D in terms of B and C. So I have B equals C over D. Well, in this case, they want me to solve for what is presently the denominator. So I know I can rewrite this and then just switch the D and the B. D and the B. So D equals C over B. Now, if I wanted to go ahead and work that out and show that I'd multiply by the denominator, the denominators cancel each other. D's cancel each other, leave me with C, and then I end up with DB. Now I want to get D by itself, so I'm going to divide by B. And what I do to one side, I'm going to do to the other. The B's cancel each other and end up with D equals CB. So you see where that shortcut comes in really handy. In this case, I have Y equals W over X. They want me to solve for, I have some variable equals some fraction, and they want me to solve for the denominator. So I'm just going to rewrite using the equal sign, the same numerator, and now I'm going to switch the X and the Y. The X is now over here, and the Y is now over here. So X equals W over Y. And that completes all of my examples for IXL Activity A1.I.9 Rearrange Multivariable Equations. Good luck with your activity.